Hello, everyone. Today we're here with Dr. Jason Oberg. He is the co-founder and CEO of Tortuga Logic. Tortuga has developed a solution to detect and prevent security vulnerabilities in silicon hardware. This is a big deal. Security is obviously a super hot space right now in the venture industry. You probably have read a lot of things in the press about what's going on with security vulnerabilities. And at the fundamental level, you want to make sure that your hardware platforms are secure. And Jason's company is working on that. So security is a red hot space in the startup world for the obvious reasons. And the majority of security companies are dealing with security situations in both software and algorithms, not really at the fundamental hardware level. Tortuga Logic operates at a deeper and more fundamental level in the silicon hardware itself, actually at the point of time of the design of the hardware, ensuring that the design is clean from a security standpoint. Jason oversees technology and strategic positioning of the company. He is the founding technologist of the company and has brought years of intellectual property into the company that he successfully transferred out of the University of California. Jason has led the company since its inception. Under his leadership, Tortuga has met all of its key milestones, including raising capital, tripling the size of the team, putting together strategic partnerships, and generating revenue on his products and services. Dr. Oberg has a BS degree in computer engineering from the University of California, Santa Barbara, an MS and Ph.D. Degree in computer science from the University of California, San Diego. So welcome, Jason.
Thanks for having me.
You bet. So how did you guys, you and your co-founder, make the decision to form Tortuga Logic?
Yeah, so we actually went through this National Science Foundation program, or sponsor program called Innovation Course. Okay. So we were at obviously doing research in this space, in hardware security. We found this program, and it's basically a startup boot camp in a sense. So they force you to talk to I think it was over 100 customers in a span of 6 weeks.
Oh, wow.
And so we really had to go out and see, is there demand for this in the marketplace? Will people buy this? What does our business model look like?
So this is as sponsored by the National Science Foundation?
Yeah, so they gave us $50,000,
okay.
or the university $50,000 that basically funded our travel expenses for the most part to do all the sort of market validation.
Okay.
So once we did that, we saw, it helped refine our business model. We saw we had a base technology that wasn't a product, and we said, okay, well, we can actually turn this into software and sell software licenses. So it helped us refine that.
Okay.
And then once we went through that, we finished, and we said, let's incorporate and let's do it. So that was
awesome.
Yeah, that was really the compelling event. So.
Okay. And this is work that you had been doing at UC for some period of time prior to the formation of the company, correct?
Yeah. So I would say Ryan Kastner, who's a professor at UC San Diego, and Tim Sherwood, who's at UC Santa Barbara, are really the pioneers in this space.
Yeah.
Right? Started doing research in this basically before anybody knew what hardware security was.
Okay.
And then Johnny and I started working with both of them, and I did my doctorate in this space. And
Johnny's your co-founder.
Johnny's my co-founder. Excuse me.
Yeah.
Yeah. So and there was over that, it's probably over about 10 years total across when we started to now that it's we have a lot of research that was done, fundamental things that weren't productizable, and then we really kind of honed in on some good stuff here. And as the market started catching up, so conferences started popping up, people started having hardware security sessions and workshops, and really saw the opportunity growing as we were. The research is always ahead of the market.
Of course,
so the market's starting to catch up. And
yeah,
that's what was compelling for us. So.
Awesome. So you guys have been around, about 3 years now?
About 3 years, yeah.
Okay. And you have real products now that you're selling.
Yep.
Was there any point in time where the original business idea, pivoted into kind of a new business idea, or you pretty much have been on the same track the entire time?
So I think there's some technical, there's a technical answer to there. I'd say that it's more about a positioning issue. So selling a software product as our business model is still kind of the core business model. And I would say the pivots we've done is actually, I was talking to you a second ago about actually doing professional services as a first engagement.
Yeah.
So that was a learning for us because there's still an education that the market needs.
Yeah.
So for certain clients, we do the services engagement, then a software license.
Okay.
So that was a very new learning that we had, rather than just straight trying to sell software licenses first thing.
Sure.
And then the the breadth of our technology, the use of it, we found is actually much more broad, and we were too focused.
Yeah.
And I think that narrowed people's perception of our product use too much. And so we found that actually it has a very broad utility of the technology, and that, for our clients was much more valuable. So that was less about a business model, about what the actual licensing model would be, but it's more around the positioning and actually conveying the broader use of how this can be applied.
Okay.
Yeah.
So for the audience, like, I've been in the semiconductor business a long time, so when you're designing chips, there's a whole flow of different tools, design tools that you use to ensure that the design works and it's properly checked out before you ever go to silicon. Right. And what Tortuga does, as I understand it, is you have modules that kind of plug into this that deal with the security issues, not just the what we call verification issues. Verification is really about, does the chip work or not work as it was designed to do, but those tools don't necessarily check for security or potential security flaws or security holes in the design flow process. So you're really operating at a fundamental level even before the chip is manufactured to ensure that there's no security issues. Is that correct?
That's exactly right. And to kind of get back to your question about a pivot, we were very focused on only, there's a whole chain of, you have several different parts of your design flow, from architectural design all the way through tape out.
Yeah.
And we were focused on only one little piece of that before, and we actually found actually our technology can apply to the whole thing.
Okay.
And so that was a really big learning for us. And I guess you could call it a pivot, but it was more of a more adequately conveying, we have a much broader set of solutions we can provide than just one thing.
Okay, so there's potential security vulnerabilities that can be introduced at any step along that design change.
Absolutely.
Okay.
Yeah.
And now you have this kind of core technology that was going after one portion of that, as I understand it, kind of in the formal verification process, which is near the tail end of the design process.
Well, it's sort of at a block level. So it's actually, I would say it's early, because and I think people know the analogies of software better, right?
Okay.
You'll build software components, and then you'll start integrating them all together.
Yeah.
So the same thing happens with hardware. People will build a hardware block.
Yeah.
They'll build a bunch of these in different groups.
Yeah.
And then they'll throw them all together and put together what they call a system on chip.
Okay.
And so at the block level, they run a lot of formal
to ensure that functionality works for that specific block.
Right.
Okay.
But formal doesn't scale to huge designs.
Yeah.
Or it's difficult to. And so as they start stitching blocks together, that's when a lot of security issues come up, because the groups didn't work together.
Right.
There's always sort of, group one built block, crypto block, group two built some other general purpose block. They integrate them together, and weird things happen. Okay. And so, it's important to do it at the block level, which we can do, but it's also important to do it at the integration stage, which we can also do.
Okay.
Yeah.
Now, in my most recent company, we bought a system on a chip company that was doing video processing system on a chips, and prior to that, when we were just doing communications products, we didn't really have the need for what was called these big emulators, these emulation systems. Mm-hmm. Does your product work with these emulators, which is basically when you're dealing with bigger, much larger system issues, not just block level issues?
Yeah, no, absolutely. We feed into those environments as well.
You do? Okay.
Yeah, so those, maybe for your audience, right? So the emulation platforms are basically a way of running your hardware environment, or running your actual silicon before you actually tape out the chips. So you can boot Linux, if you have a mobile phone processor, you could run all of Android, and you can see if this starts up. So that environment, we can actually feed our security technology in that, and you could run that whole process and see, oh wow, is there was my key mishandled during boot? Is there some weird access control configuration issue in my system on chip? Are two blocks interacting in ways they shouldn't be? So we'd be able to detect those type of issues.
Okay, cool. So you kind of work all along the chain, plus you can work up at higher levels. Now there's different suppliers, different vendors of tools, these tools that you build chips with. In fact, some of the bigger companies even have their own tools. They have custom flows. Mm-hmm. So are you agnostic to all the variety of different potential tool vendors and flows? Yeah,
absolutely. So we basically augment everything that's out there. So we don't have to, there's no requirement for you to adopt replace anything.
Okay.
Our goal is to basically take what's already there, throw some security analysis things on top. You
Okay.
can run your whole normal environment, and we'll find security issues while you're running your whole normal verification environment.
Now, is there, from a development standpoint, do you have to do special things when interfacing with, say, a cadence flow versus a synopsis flow, or it's pretty generic in terms of the hooks that are available for you?
It's pretty generic. The interfaces to those platforms are they have their own set of commands and these sort of things, but
Sure.
for the most part, we're feeding standard languages, standard
Okay.
files, so that's all standardized across the whole industry, and
Okay.
so we're using those same type of file formats and things like that.
So your product's pretty scalable,
Yeah.
in terms of, you're not going to have to do a lot of customization,
Exactly.
as you start ramping.
That's right.
How about different vertical markets? Because I know there are security issues, with Department of Defense, but also digital video and cellular phones and personal computers and Internet of Things. Can you, address all the different potential security challenges in those different vertical markets?
Absolutely. Yeah. So I think it's obvious the defense or the defense or aerospace and defense community has a lot of inherent security issues.
Sure.
And they've always, or not issues, or concerns.
Yeah.
So we've actively been targeting that market. The sort of mobile market, so the big system on chip vendors. We've actually seen a lot of demand from the storage market in data centers. Actually, data centers in general. So there's a lot of, and you wouldn't really. It's actually interesting because you wouldn't actually think of silicon security issues in a data center. It's locked in a box, but there's so many issues about resource isolation, and you're running two different virtual machines or two different jobs in a cloud environment.
Yeah.
You don't want contamination of data in the actual hardware.
Sure.
So there's a lot of initiatives related to preventing that type of thing, and then proper proper management of the boot process and these sort of things. When you take a machine down, when you start it up, can it be compromised, and these sort of things.
Okay.
And so we really have a solution that addresses security crosses. If you think about any vertical market today, there's always some security component for the most part, and
Okay.
we really can feed into all of those. So.
Okay. So before Tortuga, was there a way that chip vendors, check the security on their systems, or what was done prior to this kind of more elegant, automated way of doing things?
So what people are doing right now is pretty manual. So they'll some will just try to map it into their functional verification, which is functionality is not the same as security,
yeah.
right? It can match a functional spec, and you could have hundreds of security vulnerabilities.
Okay.
And so they'll either do that, or there's teams like product security teams, security audit teams that will do a security review once we call it the RTL is frozen. So the design files are locked down. It says the semi company says, okay, we're done building.
Yeah.
Security guys go do a review, and they'll review it. And a lot of times they find problems, but it's so costly to fix it at that point that it makes more economic sense to take the risk and try to fix it in the next generation.
Okay.
And so there's effort. They're spending dollars and time trying to do this review, but it's not very thorough, and I think that they're spending a lot of time doing this.
Okay. So kind of inefficient, not very thorough because it's manual and it's kind of hit and miss to some extent. And it's so late in the process that, there's very little that can be done other than okay, let's redesign the chip.
Right.
And that's quite expensive.
Exactly. Okay. So it's often, fixing this, would it be, 6 months ago we would have had to find that, but our platform would have actually found it 6 months ago. So,
okay.
Yeah.
Well, that's big. I mean, so obviously there's enormous market opportunity for this type of product because security touches so many things, and it's hardware. Have you guys tried to quantify, what the market opportunity is?
Yeah. So we basically broke it down. Trying to get into too much detail, but basically we broke down the customers into different tiers. So we have tier 1, tier 2, tier 3, and this. Most of those are semiconductor companies. A lot of them are aerospace defense.
Yeah.
And so we kind of summed up all of those and broke them into tiers, and then broke down how much we obviously extract the most dollars from tier 1s, a significant amount from tier 2s, and then less from tier 3s. But there's a lot more tier 3s, less tier 2s, and only a few tier 1s. And so by kind of multiplying that all out, we know the opportunity is more than $1 billion. I mean, there's there's thousands of people that buy FPGAs, these programmable chips.
Yeah.
So there's a big opportunity there. The tier 2s are like the AMDs, the Xilinxes, the Marvells, Microsemis, these of the world. And the tier 1s are like the Intels, the Qualcomms, the big staple chip makers that you would hear of. So
Awesome. So I mean, without giving away any secret sauce, I mean, can you describe kind of in layman's terms how the product works?
Yeah, sure. I mean, I think I could definitely do that. So basically, we analyze the design files. So these are when maybe give your audience some context. So when you build a chip, you write these design files. Think of it as a chip blueprint.
Yeah.
Right? So it specifies what the chip should do.
Yeah.
We load all that as an input to our software, and then we have a library of sort of security properties that we look for. So we feed that into our software as well, and then what we do is we augment the hardware with additional hardware that allows us to do a security analysis.
Yeah.
And then we pass that new design into the standard verification environments.
Okay.
So the standard tool chains from the Synopsises, the Cadences, the Mentor Graphics. Those are the big tool vendors for this industry. So we just pass that new hardware into that environment.
Okay.
And the way that we do that, it's all the standard languages, the standard files, and so it just sort of seamlessly fits into there.
Okay. Now there's, from my chip history, there's functional elements of the chip, but there's other stuff you load onto the chip to test it that, the end user never actually sees, scan chains and a variety of different things, test modes that you put into it. Does your security checking solution look at those things as well, or just at the functional blocks?
No, absolutely. Yeah. And that's actually a huge issue because, give us some more context. So, at the very end of the design process, or very near the end, circuitry is added that allows for adds test points so that when you get the physical chip back, the vendors can test the design.
Right.
And so they do that very late in the design stage and add a file format that's impossible for a human to look at.
Okay.
And so we can load that in and actually look for improper insertion of test points.
Yeah.
Did you give improper access to some key storage or some firmware that should have never been read, and these sort of things. And so we can definitely address that. And so what the end result was, if you did that before you taped out your chip, you would know that once you tape it out, that there's your keys will never be accessed from the external pins of the design of the chip. So we can absolutely address that.
Cool. So I know you guys have had some initial business success. You got some customers, you got some revenue. I mean, what's next for you guys from a business standpoint?
More revenue, more sales. No, so we have, so we're generating revenue, which is good. Right now, it's just a matter of getting more of our current products sold and more of our future products sold, and then actually helping accelerate things on our product roadmap as well. Okay. So I'd say that's, more revenue plus broader revenue, so revenue of
broader product portfolio.
Exactly. Yeah. So we have things that I mentioned this one pointed solution. We have other things that feed into other stages of the verification environment. So we'd like to start generating more revenue from the initial product, and then begin generating revenue of the next product, so that growth starts kind of be materializing a bit. So that's right now. It's been very heavily execution stage of sales. Okay. So.
And your kind of go-to-market strategy is to sell directly to the chip companies, or do you also sell to or partner with the EDA companies? These are the guys that build the tool chains for those of you that electronic design automation. Yeah. So do you sell to those guys, or you just sell directly to the chip guys, or how does that work?
So right now we're selling direct. I think we're working on partnerships right now with a couple of those big EDA vendors. I don't think the documents are not inked yet, so I don't think I can disclose anything. But basically, our end goal. They have the widest. Those guys have channels across the entire planet.
Sure.
So, ideally, that's where we'll go. Do co-selling, co-marketing actually, or have them as actual sales channel. Okay. So that's definitely on our radar, and that's what we're.
And you're not really competing with those guys. And you also are agnostic and can sit on top of multiple environments.
Yeah. So I think we personally view them as competition. I'd say our biggest competition are them, as well as the actual semi companies as well, because they're investing dollars to build product security teams, and
they have to.
Some of these companies already have rigorous processes in place, and so for us to say this is how you should do it ends up being a barrier to entry sometimes. But the work that a lot of the big EDA companies have done, at least to this point, has been they have not taken a huge jump yet for security. So right now it's very complementary. I don't view them as a direct competitor, but I think that from an external view, they're definitely, you could see them as a competitor, and they could be as they start investing more into this space. Sure.
So what intellectual property do you have in the products? Do you have patents, or do you have trade secrets, or what do you have, and kind of what are you doing to protect it?
Yeah, so we have 2 patents that the University of California owns. We have exclusive licenses to those. So a lot of this technology was born out of UC.
Yeah.
So those are granted. Mm-hmm. So they've been granted, and we have like I said, the exclusive license agreements all completed with the university.
Yeah.
Then we have an additional patent that we have pending right now that we filed on behalf of the company. And then we have probably three more or so in the pipeline that we want to do. So.
Okay. Have you taken any outside investment, and do you see yourself being a standalone long term, or a potential acquisition target?
Yeah, so I think answer the first question. So we've raised some early capital, seed investment, and we also have a pretty sizable grant from the National Science Foundation. So a small business grant, their SBIR program.
Okay.
So we're well funded for the stage of the company, I'd say. And then in terms of the second question, I think that there's really, we're very focused on making a sustainable business.
Yeah.
And I think this can be a big sustainable business, but I mean, we're very unique, and I think it's not unrealistic that one of the bigger companies out there would, because security is a big issue right now, that they'd want to own that because it would give them a competitive advantage.
Okay.
So I think it's not unrealistic that we could get acquired and complement some of these existing technologies.
Okay. So for the entrepreneurial audience out there, I mean, this is your first company, first time entrepreneur, came out of academia.
Yep.
You have a research environment. So having done this now for 3 years, is there any kind of wisdom that you can impart for folks out there that are looking to start a company, or have been running it, or any of those kinds of things?
Yeah, I mean, I think it's going to sound weird from a technologist, but I found that really the technology doesn't matter, or it matters not as. The bigger issue is more of you really need to understand what your customers' problems are, and then figure out the business value around their issues, and then figure out how your technology can address that. Going to a meeting, and I see this in presentations all the time. So what's the business value? And they say, we have a security platform because it finds security bugs. I mean, that has no business value, that doesn't translate into dollars. And so really trying to hone in on what the business value is of your products is sort of the big learning I had.
Okay.
And then really, think in addition to the technology doesn't matter as much, I mean, I obviously think this is like the greatest thing ever, and making sure that it's, we have I think it's the same answer. Focusing on this technology is the greatest thing that's going to solve all the problems.
Yeah.
And really, you need to hone in on that business value, and that's I think a big issue most technology-centric founders run into. I see it in lots and lots of presentations.
Yeah.
So I tell myself that every day.
Yeah.
Like, what's the business value of what you're doing?
Yeah.
And if you can't convey that well, then you need to.
Yeah. So you really have to learn
that.
the customer's business to a great extent,
Right.
and kind of look at things from their lens, from their perspective.
Exactly.
And then, how can I help solve problems that they have?
Right.
And you touched on a lot of that. I mean, so you've clearly kind of come down the learning curve as far as that goes, because I mean, they have a huge problem, and it's costing them a lot of money. It costs them potential embarrassment.
Exactly.
And the time frame that they catch these problems is pretty late. So I think that this is really cool. Really appreciate you taking the time.
Yeah.
And this is Patrick Henry, the CEO of QuestFusion, here with Jason Oberg, with the real deal, what matters.
Yeah. Thanks, Patrick.
You bet.
Thanks.